All right, welcome to the deep dive. Today we're going way out there. We're talking about intergalactic travel. I know it sounds like pure science fiction,
But
right?
like Star Wars or something.
Exactly. But we actually dug up a whole bunch of articles and research papers, and they're all looking at the question seriously. Could we actually travel to other galaxies?
Yeah, forget the Death Star and the laser swords for a minute. This stuff gets really, really interesting when you start looking at the actual science and the mind-blowing ideas people are coming up with.
And that's exactly what we're going to do in this deep dive. We're going to try to uh, distill it all down for you. What would it actually take to journey between galaxies? What are the real hurdles, and what are some of these out there ideas that scientists are exploring?
Exactly. We want to give you a solid grasp of the whole thing. What would it really involve? What are the biggest problems to solve? And what are some of the truly crazy possibilities?
So, the first thing that kind of hits you right off the bat is just the sheer scale. I mean, space is big, we all know that, but going to another galaxy is a whole other level of big.
It's almost impossible to wrap your head around.
Totally. Our own galaxy, the Milky Way, it's like 100,000 light years across.
Yeah, just let that sink in for a second. It takes light, the fastest thing in the universe, 100,000 years to cross our galaxy.
And that's just our little corner of the universe.
Right. When you look at the distances between galaxies, it's astronomical. Our closest big neighbor, the Andromeda Galaxy, that's 2.5 million light years away.
2.5 million.
Yeah. And to give you a slightly closer but still incredibly distant example, the closest star system to us is Alpha Centauri. That's about 4.5 light years away.
Okay, so even if we could travel at, a good chunk of the speed of light, which we definitely can't right now, it would still take thousands of years to get to the nearest star system, let alone another galaxy.
Absolutely. And the fastest spacecraft we've ever built, the Parker Solar Probe, that tops out at about 430,000 miles an hour.
Wow, that's fast.
It is. But even at that speed, it would take something like 17,000 years to reach Alpha Centauri. And to get to Andromeda, forget about it, we're talking 6 million years.
So it's pretty clear that the way we get around in space now, with chemical rockets, that's just not going to cut it for intergalactic travel.
Not even close. Chemical rockets are great for getting us into orbit and exploring our own solar system, but when you're talking about crossing those immense intergalactic distances, they don't have the juice.
They don't have the stamina, I guess.
Exactly. They just can't provide the kind of sustained acceleration you'd need to even get close to the speed of light. Plus, even if they could, the amount of fuel you'd need for a trip like that is mind-boggling. It would be completely impractical.
And then there's the whole problem of keeping people alive for, well, thousands or even millions of years.
Right. You need life support systems that can work flawlessly for millennia, protection from deadly cosmic radiation for that long, and the spacecraft itself would have to be built to withstand a journey like that. We're talking about engineering challenges that are just off the charts.
So it seems like we need some kind of crazy sci-fi solution.
Yeah.
Some way to cheat the system, maybe even bend the laws of physics.
Yeah, I mean, if our current tech is like trying to row across an ocean, we need something more like, I don't know, teleporting.
Teleporting, exactly.
And this is where the idea of faster than light travel, or FTL, comes in. Now, Einstein's theory of relativity tells us that nothing can travel faster than light. It's like the cosmic speed limit.
Right.
But some really brilliant physicists have come up with ways we might be able to get around this limit, not by actually going faster than light, but by warping space-time itself.
Okay, warping space-time. That sounds pretty out there.
It is, but it's based on the idea that space and time are actually interconnected. When we talked about bending space, we're also affecting time, and vice versa.
Gotcha. So what about warp drives? I've heard about those in science fiction. Are they actually a possibility?
Well, the most famous concept is the Alcubierre warp drive, and it was proposed back in 1994. The idea is that you wouldn't actually be moving the spacecraft faster than light. Instead, you'd warp space-time around the ship. Imagine creating a bubble of space where space in front of the ship is compressed and the space behind it is expanded.
So the ship is just kind of riding along inside this bubble.
Exactly. It's like surfing a wave of space-time.
Wow. But is this even remotely possible with our current technology?
Honestly, it's a long shot. While the math of the Alcubierre drive does work out on paper, the engineering challenges are immense. For one thing, it would require something called exotic matter. This is matter with negative mass density, which is just bizarre.
Negative mass density, what does that even mean?
It means, like, if you pushed it, it would move towards you instead of away. We've never actually observed this kind of matter, and we have no idea how to create it. Plus, the energy requirements would be colossal, probably more than the total energy of a large planet.
So warp drives are more of a fun thought experiment than a realistic possibility for now.
Yeah, pretty much.
Okay, what about wormholes? Those are another sci-fi staple. Could those be a way to travel between galaxies?
Wormholes are really interesting. They're like tunnels or shortcuts through space-time that could connect two very distant points in the universe.
So you could step into one end of a wormhole and instantly come out millions of light years away.
Theoretically, yes. But like with warp drives, there are some huge obstacles.
Yeah,
We haven't actually proven that wormholes even exist, and even if they do, they'd probably be tiny and unstable, collapsing almost immediately.
not very useful for a spaceship.
Not really. To make a wormhole that a spacecraft could travel through, you probably need that exotic matter again to hold it open. So wormholes are still very much in the realm of theory.
Okay, so warping space-time is still a big question mark. But what about some more, well, down-to-earth ideas? What about generation ships?
Generation ships are a totally different approach to intergalactic travel. Instead of trying to go super fast, the idea is to just accept that the journey will take a really, really long time and build a massive, self-sustaining spacecraft that can support multiple generations of humans.
So the people who start the journey wouldn't actually reach the destination. It would be their descendants.
Exactly.
That's pretty wild. What kind of tech would you need to make that even remotely feasible?
The most important thing would be a closed-loop life support system. You'd have to recycle literally everything.
Yeah.
Air, water, waste products, you name it.
Sounds complicated.
It would be incredibly complex. You'd also need a super efficient way to produce food, probably using advanced hydroponics or something similar. The whole ship would basically have to be a giant self-contained ecosystem.
And wouldn't that raise a whole bunch of uh, ethical questions? I mean, what would life be like for people born and raised on a spaceship, traveling to a destination they might never see?
Oh, absolutely. How would their society develop? Would they feel any connection to Earth, a place they've only heard stories about? Would they even want to continue the mission? These are all huge philosophical questions that we'd have to grapple with.
It's pretty mind-blowing to think about. So while FTL travel is still highly speculative, generation ships seem like a more realistic, albeit incredibly long-term solution. But even with generation ships, we'd still need a way to get them moving fast enough to make the journey even remotely feasible, right?
Absolutely. And that brings us to some of the more advanced propulsion concepts that are being explored. We're not talking about breaking the speed of light, but we are talking about getting significantly faster than we can with chemical rockets.
So what are some of these next-generation propulsion systems?
Well, two of the most promising are fusion propulsion and antimatter propulsion.
Fusion propulsion. That's based on the same process that powers the sun, isn't it?
Right. It involves forcing atoms together under immense pressure and heat, which releases tremendous amounts of energy.
And we could use that energy to power a spacecraft.
Exactly. Fusion propulsion is a very promising technology for deep space travel. It could allow us to travel much faster and farther than we can with chemical rockets.
And what about antimatter propulsion? That sounds like something straight out of Star Trek.
It does, but the science behind it is solid. Antimatter is like the opposite of matter. When matter and antimatter meet, they annihilate each other, releasing a massive amount of energy.
And that energy could be used for propulsion.
Exactly. Antimatter propulsion is incredibly efficient, and it could potentially allow us to get really close to the speed of light.
But I imagine there are some challenges with antimatter, right?
Oh, definitely.
Yeah.
The biggest hurdles are producing and storing antimatter. It's extremely difficult and expensive to create, and we have no good way to store it safely. It annihilates on contact with regular matter.
It sounds tricky.
It is, but the potential payoff is so huge that research is continuing.
Okay, so we've talked about the challenges of distance and propulsion, but there's also the problem of, keeping a crew alive and functioning for potentially thousands of years.
Right. That's where artificial intelligence and robotics come in. For really long missions, especially multi-generational ones, AI and robots could be essential.
Essential in what way?
Well, for one, advanced AI could manage the spacecraft. Think about it. AI could monitor and adjust life support systems, navigation, communications, all sorts of things. It could also do scientific research, analyze data, and even make decisions in response to unexpected events.
So like a super smart mission control, but on board the ship.
Exactly. AI could also help with the psychological aspects of a long space journey. It could provide companionship, entertainment, and even counseling for the crew.
Sounds like a pretty important role.
Absolutely. And then there are robots. Autonomous robots and drones could be sent ahead to scout out potential destinations, gather data, and even start building basic infrastructure.
Interesting. So it seems like intergalactic travel isn't just about overcoming technological challenges. It's
Yes.
also about confronting some really fundamental questions about our place in the universe.
You got it. I mean,
Yeah.
what happens if we encounter alien life? What are the ethics of colonizing other planets? What happens to human society on a multi-generational spaceship?
Yeah.
These are all things we have to think about.
Big questions for sure.
Huge questions. And then there are the even weirder possibilities. Did you come across the idea of hypervelocity stars?
I did, yeah. That was pretty mind-blowing. Stars that are basically flying through space at crazy speeds.
Exactly. They've been ejected from their galaxies and are hurtling through intergalactic space.
And the idea is to hitch a ride on one of these stars.
That's the incredibly long-term plan. It would take millions, maybe even billions of years, but a sufficiently advanced civilization might be able to do it.
Talk about a long-term investment.
Seriously. And then there's time dilation, another crazy concept from Einstein's theory of relativity.
Time dilation.
Yeah, it means that time passes at different rates for objects that are moving at different speeds. The closer you get to the speed of light, the slower time passes for you relative to someone who's standing still.
So even though it might take millions of years to travel to another galaxy, from Earth's perspective, the people on the spaceship might only experience a few decades.
Right. One of the articles we read gave an example. A rocket constantly accelerating at the same rate as Earth's gravity would reach Andromeda in about 28 years, from the perspective of the crew.
That's wild. But I guess actually achieving those kinds of speeds is a whole other challenge.
Totally. It's definitely beyond our current capabilities, but it's still fascinating to think about.
So even though intergalactic travel seems impossible right now, the laws of physics might actually offer some pretty crazy workarounds.
That's the exciting part. What seems impossible today might not be so impossible in the distant future. After all, we humans have a history of accomplishing amazing things. Think about it. Space travel itself was once considered pure fantasy.
True, true.
And while it might take centuries or even millennia to actually achieve intergalactic travel, the theoretical possibilities are there, and our understanding of the universe is constantly evolving.
So it's not just about technology. It's about our imagination, our ethics, our drive to explore.
Precisely. It's about pushing the boundaries of what we think is possible and asking those big, fundamental questions about our place in the cosmos. What's our purpose? What's our legacy? What does it even mean to be human in a universe of unimaginable scale?
It's a lot to think about.
It is, and it's these closed questions that drive us forward as a species.
I agree. So while intergalactic travel is a long way off, just thinking about it can change our perspective. It makes our everyday worries seem smaller, and it inspires us to dream bigger.
Absolutely. And that's the beauty of exploration. It forces us to confront the unknown and to imagine what might be possible.
Well said. Thanks for taking this deep dive with me. It's been pretty mind-blowing.
My pleasure. It's always great to chat about these big ideas.
And thanks to all of you for listening to the deep dive. We've covered a lot of ground today, and I hope you're leaving with as much to think about as I am. If you were to launch an intergalactic mission today, what would be its purpose? What message would you want to send to the universe, or to your own descendants thousands of years from now? It's a question that deserves some serious pondering. Until next time, keep exploring.